Let us start with summation. We all know that we have seen the concept of delta, right? Delta yt equal to yt plus 1 minus yt, right? इस टाइप का कंसेप्ट था अपना डेल्टा yt इक्वल टू yt plus 1 minus yt. This delta is called difference operator. It is parallel with what? Derivative d by dx, like this. That is derivative of f of x with respect to x. ये d by dx के लिए जो भी parallel था, we all seen with this delta. We have seen its addition of two functions, means delta of addition of two functions, delta of subtraction of two functions, delta of product of two functions, delta of quotient of two functions also, right? So we know this. What about delta? And we obtain delta of so many fundamental what we can say that functions, that is delta of a to the power t equal to, we seen it is a minus 1 into a to the power t. It is like this, a minus 1 into a to the power t, correct? So in this way, now we know that we know the concept of integral also. What is the concept of integral now? इंटीग्रल की कंसेप्ट हमें सबको पता है. व्हाट इज इट? इफ d by dx of f of x equal to g of x, then we know that integral of g of x with respect to x equal to something f of x, correct hai? This is the concept of integral, right? If d by dx of f of x equal to g of x, then integral of g of x, इसका जो integral है, it will become f of x with respect to x. Sometimes we call integral as antiderivative or antidifference, right? Sometimes we call integral as antiderivative or sometimes we or converse of derivative or inverse derivative, whatever you want, or reciprocal, we can say that inverse of derivative. So integral is the inverse function of derivative. What means that if d by dx of x to the power n, इसका अगर डेरिवेटिव पता है हमें क्या है, n into x to the power n minus 1, then we say that integral of n into x to the power n minus 1 is only x to the power n. We know this. Therefore integral is also called antidifference of antiderivative. In the same way we'll go for difference also. Difference का भी concept parallel to integral है, parallel to integral. That means what? If delta of yt equal to zt, if delta of yt equal to zt, then summation of zt equal to yt. Then summation of zt equal to yt. That means summation is the anti-difference of delta. Summation is the anti-difference of delta. This is a simple concept which is parallel to integral. Parallel to integral. जिस तरह डेरिवेटिव ऑफ f of x अगर g of x है, तो हम बोलते हैं कि इंटीग्रल ऑफ g of x is f of x. In the same way, अगर डेल्टा ऑफ yt इक्वल टू zt है, तो हम बोलेंगे कि summation of zt equal to this yt. So summation is nothing but anti-difference of summation is nothing but anti-difference of a function. Anti-difference of a function, or summation is something anti-difference. Okay, this is a clearly concept. That means what? कि summation of yt and its delta अगर ले लिया हमने, what will we get? It is only yt. जिस तरह से integral of g of x with respect to x, and again if I take derivative with respect to x, then what you will get only? It is only g of x. So in the same way, summation of yt and its delta is nothing but yt. Hence we can say that summation and delta are इनवर्स फंक्शंस ऑफ ईच अदर. ये दोनों क्या है? इनवर्स फंक्शंस ऑफ ईच अदर. yt ले लो, उसका समेशन ले लो, उसका डेल्टा ले लो, we will get only yt itself. This clearly implies that कि if delta of yt equal to something zt, then summation of right hand side zt equal to something yt. Summation of zt equal to yt. Now I will talk. Okay. So we have got the concept of summation. It is a very simple summation concept. What concept is there? If if delta of yt equal to zt, then summation of zt equal to yt. Therefore, what is the definition? Definition is like this. An indefinite sum or antidifference of yt denoted by summation of yt is any function so that if I find delta of summation of yt, you must get yt. If we find delta of yt, delta of summation yt is equal to yt. Right? For all t in the domain of y. For all t in the domain of y. So this is the very simple definition of what we can say that summation. Right? This is the definition of summation. So what is that summation? Summation of yt is nothing but such a function whose delta must be itself. Or another definition is like this. If delta of yt equal to zt, then summation of zt equal to yt. This is simple definition of the summation. Okay. In integral, we have seen one thing. If integral of g of x with respect to x equal to something f of x, तो हम क्या लिखते हैं यहाँ? g of x का इंटीग्रल अगर f of x है तो we always write it as f of x plus integrating constant c. पता है आपको? We always write integral of if g of x का इंटीग्रल अगर f of x है, then we write integral of g of x as f of x plus integrating constant c there, plus integrating constant c, right? So in the same way, we have this rule also there. If zt is an indefinite sum of yt, then every indefinite sum of yt is given by summation of yt equal to zt plus c of t, where c of t has the same domain as y and delta ct equal to 0. क्या होना चाहिए यहाँ? सिर्फ ऐसा फंक्शन ले रहे हैं हम ये c of t whose delta is equal to 0. Whose delta equal to 0. Its proof is again parallel with that integral. Suppose let summation of yt equal to zt. We have given that is if zt is an indefinite sum of yt. So what we can take? Suppose that summation of yt equal to some zt. That is zt is the summation of yt. Then we know that by using the definition, delta of zt must be equal to yt. Therefore, yt equal to delta of zt. yt equal to delta of zt आना चाहिए, बराबर? So now if we consider any function t of c of t whose delta is 0, suppose c of t is any function whose first forward difference is 0, then can we say that delta of zt plus ct is equal to delta of zt plus delta of ct? We know the formula for addition of two functions. If we want to obtain delta of addition of two functions, then we can take their separate delta, delta of zt plus delta of ct. We know that how ct we have considered, whose delta is equal to 0. So delta of ct equal to 0. So it is equal to only delta of zt आ जाएगा. And what is your delta of zt? Is your yt. So it is equal to yt plus 0, which is equal to yt. So what we proved? Delta of zt plus yt ct is equal to only yt. delta of delta of zt plus ct equal to yt. So again we use the definition of summation. So delta of zt plus ct is equal to yt implies summation of yt equal to zt plus ct. So this will give summation of yt equal to zt plus ct, where delta ct equal to 0. So what we proved? If summation of yt equal to zt, if summation of yt equal to zt, then what we prove? Summation of yt is also equal to zt plus c of t, where first difference of c of t equal to 0. So now henceforth, if we know the indefinite summation of some function, then we can write the indefinite summation of that function as that summation solution plus c of t, where delta of c of t equal to 0. Okay, delta of c of t equal to 0. Now that we have proved, right? I think where we go. Yes. Right. This we have proved. Now we will see one example. Compute the indefinite sum of summation of 6 to the power t. Compute the summation of 6 to the power t. How we prove it or how we find it? We know that delta of 6 to the power t is equal to 5 into 6 to the power t, because its formula is what? Delta of a to the power t equal to a minus 1 into a to the power t. So by using that formula, what you will get? What you will get? Delta of 6 to the power t equal to 5 into 6 to the power t. Therefore, can I write delta of 6 to the power t upon 5 equal to only 6 to the power t? And therefore, by using definition, summation of this 6 to the power t becomes 6 to the power t upon 5. So summation of 6 to the power t equal to 6 to the power t upon 5 plus ct, where delta of ct equal to 0. Where delta of ct equal to 0 there. Okay. Now, okay. Corollary. Let yt be defined on a set of the type a plus 1, a plus 2, where a is any real number, and let zt be an indefinite sum of yt. Then every indefinite sum of yt is given by summation of yt equal to zt plus c. What is the change here only? The c of t is replaced by c only. What is c? C is a constant term. And what is that above ct? This was the function ct whose delta is equal to 0. We know that the delta of constant term is always equal to 0. So in place of this ct, you can consider c also. But when we can consider it? If the domain set of this type, means difference between every two consecutive terms is equal to 1 and a is a real number. For example, if I consider set of natural numbers here, then you will get c as a constant. We'll see this by example. So if your domain set, the values of t are of this type, a plus 1, a plus 2, and so on. That is, for example, 1, 2, 3, 4, 5, 6, 7, 8, etc. If the values of t as set of natural number, then you can consider the c of t as only constant function, as like integer, okay. Consider the domain set is integers. Integers means 1, 2, 3, plus or minus 1, plus or minus 2, plus or minus 3, and etc. For example, consider n is equal to set of natural numbers 1, 2, 3. Then delta of ct becomes ct plus 1 minus ct equal to 0. Delta ct equal to 0 means what? ct plus 1 minus ct equal to 0. इसमें क्या करना है? We have to show that if your t belongs to set of natural numbers, then delta ct equal to 0 implies ct equal to c. That is constant term. यही हमको प्रूव करना है. So we have to obtain such a ct whose delta is 0 in case your t are natural number, set of natural numbers, और उसमें हर एक में डिफरेंस क्या आता है? Only one. उस हर एक में डिफरेंस क्या आ जाएगा? Only one. So for t is equal to 1, 2, 3, and so on. Now what this implies? Delta ct equal to 0. What it implies? It implies if I put t is equal to 1, what you will get? C of 2 minus C of 1 is equal to 0. C of 2 minus C of 1 equal to 0. What is mean by that? C of 1 equal to C of 2. If I put t is equal to 2, what you will get? C of 3 minus C of 2 equal to 0. That is C of 3 equal to C of 2. Hence, if I take n is equal to 1, 2, 3 or t is equal to 1, 2, 3 and so on, what you will get? It implies C of 1 equal to C of 2 equal to C of 3 equal to so on. ये सब values equal आएगी. That means what? अगर ऐसा कौन सा function है? Y at 1 equal to y at 2 equal to y at 3 equal to y at 4, isn't it? इस type का आता है, then it is only a constant function. So if your C of t equal to something 10, then your C of 1 equal to 10, C of 2 equal to 10, C of 3 equal to 10, C of anything equal to 10 will be there. And therefore this will satisfy. So this will satisfy only if C of t must be a constant number. That is C of t equal to something C. And therefore, if your t belongs to set of natural numbers and delta ct equal to 0, then C of t must be constant. That is there only, we have written. On the other hand, if the domain of y is the set of real numbers, suppose that concept real number, then delta ct equal to 0 implies C of t plus 1 minus C of t equal to 0. That is C of t plus 1 equal to ct for all real t. That is C is a periodic function. ये किसका है? This is a periodic function. We know that sine function is periodic, cos function is periodic, and so on. Sine and cos functions are periodic functions. We know that. I will take one example there where C of t plus 1 equal to C of t, but it is not constant function. C of t plus and why that will happen? Because we have t considered here set of real numbers, and here t consider your set of natural numbers. So if your domain set is integer or natural numbers, then delta ct equal to 0 implies ct equal to c. If the domain set is not natural number or integers, it is any real number, then set delta ct equal to 0 implies periodic function. That implies periodic function. Now, its example is this one. That is, C can have a periodic function having period 1. For example, I will take C1 of t equal to 2 into sine 2 pi t. C1 of t equal to 2 into sine 2 pi t. Or C2 of t equal to minus 5 times cos 4 pi into t minus pi. Now consider C1t. I will let C1t is equal to this. Therefore, C1t plus 1. What will be C1t plus 1 now? C1t plus 1 क्या आएगा? 2 sine Here t is replaced by t plus 1. If I replace t by t plus 1, what you will get? 2 pi into t plus 1. That is 2 pi t plus 2 pi. 2 pi t plus 2 pi. So 2 sine 2 pi t plus 2 pi. We know that sine function is a periodic with 2 pi. That means sine of theta is same as sine of theta plus 2 pi. We know that sine of theta is equal to sine of theta plus 2 pi, and therefore now this 2 sine 2 pi t plus 2 pi becomes 2 sine only 2 pi t again. And what is 2 sine 2 pi t? It is again c1t. So what you obtain there? C1t is same as c1 t plus 1. C1t is same as c1 t plus 1. Correct? So this c1t is a periodic function with period 1. So for now any real number t, c1t plus 1 equal to c1t, and this is not now constant function. ये constant function है क्या? नहीं है. This is not a constant function. So though this is not a constant function, c1t plus 1 equal to c1t, that is delta c1t equal to 0 we get. So there may be such types of functions, right? Similarly for this, c2t equal to minus 5 times cos 4 pi into t minus pi. If I replace t by t plus 1, what you will obtain here? c2t plus 1 becomes minus 5 cos 4 pi into t plus 1 minus pi. That is minus 5 cos 4 pi t plus 4 pi into 1 minus t, 1 minus pi. It is a scalar multiple of 4 pi. It is a multiple of 4 pi. So what you will obtain? That is minus 5 cos of 4 pi into t minus pi plus 4 pi. 4 pi can be taken here, and here I will write. So now कितने का difference है? 4 pi का. Again cos function is a periodic with period 2 pi. 2 pi means if I add 4 pi in this angle, answer remains same. So minus 5 cos of 4 pi into t minus pi you will get again, which is c2t. So c2t equal to c2t plus 1. Therefore delta c2t is equal to delta c2t equal to क्या आएगा यहाँ? Delta c2t is equal to c2 delta c2t is equal to c2t plus 1. That is c2t is a periodic with period 1 now, and therefore in this summation where it is here, if set is means domain set is set of natural numbers, then you can write summation of yt equal to zt plus c. If this domain set t is not set of natural numbers or not set of integers, then summation of yt can be written as zt plus c of t, where delta c of t equal to 0. That is this result. Okay. Now, as we have seen, the formula for obtaining delta of some standard functions, you can also find the formula for summation for same standard functions. So those formulae are here, which are very again easy. Let a be any constant, then for delta ct equal to 0, number 1, summation of a to the power t equal to a to the power t upon a minus 1 plus c of t, where a not equal to 1. Because if a equal to 1, this denominator becomes 0 and this total becomes invalid, that is infinity, and therefore we omit that condition here, a is not equal to 1. Second is summation of sin at equal to this one, summation of cos at equal to third one, summation of log t equal to this one, and then lastly I think one more there is, yes, summation of t to the falling a is equal to t to the falling a plus 1 upon a plus 1 plus c of t, where a is not equal to 1. Then summation of a plus tca equal to tca plus 1 plus c of t, and summation of a plus t ct equal to a plus t c t minus 1 plus c. How we can prove this? This first one. What is the delta of a to the power t? We know that delta of a to the power t is a minus 1 into a to the power t. So what will be delta of a to the power t upon a minus 1? This is equal to a1 upon a minus 1 as it is into a minus 1 into a to the power t, right? A minus 1 into a to the power t. So a minus 1 cancels with a minus 1, provided a is not equal to 1. This will get only a to the power t. Therefore, delta of a to the power t upon a minus 1 equal to what? A to the power t. Hence, summation of a to the power t becomes a to the power t upon a minus 1 plus. Now we know that C of t, where delta of C of t equal to 0. So proof is very simple. Similarly, we want to obtain summation of sin at. Now, for that, we will find delta of cos this one. Now we have the formula for finding delta of cos at. Then we have the formula for finding delta of sin at. We have the formula for finding delta of log of gamma t. Then this one and this one. We'll see one by one. Very easy proofs. First proof we have seen. Second, we have delta of cos a t minus 1 by 2 upon 2 sin a by 2. So 1 upon 2 sin a by t outside, we will find only delta of cos a t minus 1 by 2. We have the formula for cos a t. Delta of cos a t का formula क्या है अपने पास? Delta of cos a t equal to क्या है? Minus 2 sin a by 2, right? Into 2 sin a by 2 into sin of क्या था? t by 2 t minus 1 by 2 something. T minus and a was there, right? A into t minus 1 by 2. That formula was there, I think, right? So what will happen here? Only you want to replace t minus 1 by 2 by t here. So 1 upon 2 sin a by 2 into minus 2 sin a by 2 into sin at becomes. If I replace t minus 1 by 2 as at, it will be your sin at. Now this 2 sin a by 2, 2 sin a by 2 cancel. We get only minus sin at. Therefore, as delta of this whole, cos a t minus 1 by 2 upon 2 sin a by 2 is minus sin at. Therefore, summation of this minus sin at becomes this one. Again, minus you will take it here. So we get summation of sin at equal to cos of a into t minus 1 by 2 upon 2 sin a by 2 plus c of t, where delta ct equal to 0 already given in. Here a is not equal to 2n pi. Why a is not equal to 2n pi? If I take a equal to 2n pi, then this whole term becomes 0. Sin 2n pi upon 2 means sin n pi equal to 0. Sin n pi 0 means this total term has infinity. Similarly, we can prove for next result. We know that delta of sin of a into t minus 1 by 2 upon 2 sin a by 2 equal to 1 upon 2 sin a by 2 as it is 2 sin a by 2 into cos a t equal to cos a t, and therefore summation of cos a t equal to this whole term plus c of t. Again, as denominator is sin a by 2, so a should not be equal to 2n pi. Very parallel proof is there. Now, we know that delta of log of gamma t is equal to log t. We prove this formula. Delta of log of gamma t equal to log t. So, summation of log t must be equal to log of gamma t plus c of t there, where delta ct equal to 0. Again, since delta of a to the t to the falling a plus 1 upon a plus 1 equal to 1 upon a plus 1, t to the falling a plus 1 का delta पता है हमको, a plus 1 into t to the falling a, which is equal to simply t to the falling a, and where a is not equal to minus 1. Why it is minus 1? Because if a is minus 1, then this becomes 0. This total term becomes meaningless. Again, delta of tc a plus 1 equal to tca. We know the formula for delta of tca. tca का formula है आपको tc a minus 1. एक कम हो जाता है यहाँ से. So delta of tca plus 1 is tca. Here this term is decreased by 1 now. Okay. Therefore, summation of tca is equal to tca plus 1 plus c. And lastly, delta of a plus tct minus 1 equal to a plus tct, because while finding delta of t plus r t minus 1 equal to t plus r t, we know that. This is the formula for finding a plus tc t minus 1, यहाँ एक ऐड हो जाता है अगर ये ये this term is variable not constant. So delta of a plus tc t minus 1 equal to a plus tct. Therefore summation of a plus tct equal to a plus tc t minus 1 plus c of t. So we proved all the formula, I think there, basic formula. So this is a very parallel with what? Integral. It is very parallel with integral. How it integral? Means what? If delta of yt equal to zt, then summation of zt equal to yt. Right hand side का summation ही आ जाएगा. And after that we can write c of t, where delta of c of t equal to 0. And then what? Second thing is what? If this t is set of either integer or natural number, then and delta ct equal to 0 implies ct equal to c, and if it is real number, then delta ct equal to 0 implies ct is a periodic function. So very simple concept of summation is there. Okay.